Good afternoon, everyone. Welcome back. Yesterday, we are talking about probability, and we will be continuing with the topic today. Yes. Good afternoon, Rohan, Rohini, Bhargavi, Lakshita, Diksha, Bhumika. Yes. Very good afternoon to all of you. Okay. So, we have done some sums. So, before that, I'll just quickly revise, saying that probability you can have simple or composite. Simple is which cannot be decomposed into another events, and composite events are events that can be broken down into simple events. Okay. Now, what is meant by mutually exclusive events or incompatible events are that occurrence of one implies non-occurrence of all other events. So P of A union B will be equal to P of A plus P of B. Okay. In mathematical terms, it will be P of A union B is equal to P of A plus P of B. Exhaustive events is the set of all possible events that can occur. So the probability total of all the events should come to 1. Okay. So if I am doing an experiment and if I'm adding all these probabilities of events that are occurring, all that can occur, then when I add the probabilities, that total should come to 1. When that happens, we say that we have considered exhaustive events, means there can be no other events apart from the events that we have mentioned. Then third is equally likely events, mutually symmetric events, or equally probable events. Okay, they all mean one and the same thing. So you must know the terminology. Equally likely events means, as the simple word suggests, each event has a equal probability of happening. They are also called as mutually symmetric events or equally probable events. Okay, each event is equally likely, so P of A is equal to P of B. So that, for example, when I toss a dice, so the possibility of getting 1 on the head or 2, 3, 4, 5, 6, all is equal to 1 by 6. Okay. Then we talked about the classical definition of probability and the Bernoulli-Laplace definition of probability. Then we are talking about expected value, that is mu is equal to summation x into p. X is like we have in frequency distribution, so we have the class interval. Similarly, you will have x from there, and p will be probability of that class interval happening, okay, or that event happening. So x into p. Then you will find p e of x square, which is equal to summation x square into p. So what we have done in the expected value is x into p. Now e of x square will be x square into p and then summation. That will give us what? That will give us variance. Sigma square is equal to e of x square minus mu square. Okay. So what we are going to do is we are going to say, let me write it with a different color. Okay. So we are going to say mu is equal to summation x into p. Then we will talk of e of x square, which will be equal to summation x square into p. Then we have variance, which is equal to e of x square minus mu square. Okay. And once I have variance, I can easily find standard deviation, which is equal to square root of variance. Okay. Is it clear? Okay. Now, what are the properties of probability that you should keep in mind is that probability value will always be less than or equal to 1, and it is a non-negative number, so it will be greater than 0 but less than or equal to 1. Okay. Then if A is an impossible event, what will be its probability? Its probability will be 0. If A is a sure event, that is this event is going to occur 100%, then we say probability is equal to 1. Non-occurrence of an event is denoted by A dash. We have already done in chapter 1 sets. So that is equal to A dash. Then always remember that P of A, that is probability of A occurring, plus P of A dash, that is probability of A not occurring. These together should be equal to 1. Okay. Then From this, we can also find out probability of non-occurrence. Probability of non-occurrence is given by P of A dash is equal to 1 minus N of A upon N. What is N of A? N is the favorable events and N is the total number of events. Then this is also important. Odds in favor of A. So when we are talking about odds in favor, we will talk it as N of A to the ratio N minus N of A, and odds against N against A will be N minus NA up is to N of A. Okay, so odds in favor and odds against. Okay. Then there are a few other formulas, summation. Okay. So you know this general formula, N of A union B is equal to N of A plus N of B minus N of A intersection B. That is like that can be extrapolated to probability, which is P of A union B is equal to P of A plus P of B minus P of A intersection B. Then second formula is P of B given A is equal to P of A intersection B upon P of A. So here the trick to remember is that whatever is after the slash sign will always come in the denominator. So P of B given A will be equal to P of A intersection B upon P of A. Then P of A intersection B will be equal to, then I cross multiply. So P of A intersection B can also be, I have this formula P of A into P of B given A. Okay. Then P of A minus B plus P of B minus A is equal to PA plus PB minus 2 of PA intersection B. So that what is A minus B? That A, only A, exclusive A without any B. So when we are talking of only A, so that we don't have the intersection, we are considering pure A. So P of pure A plus P of pure B will be equal to P of A plus P of B minus 2 times P of A intersection B. Because what is common, I remove. Then what is common between set A and set B, if I remove, what will I be left with? Pure A and pure B. Okay. Then expected frequency is N star is P is equal to N into P of A union B. Okay, because usually these experiments are done on a sample, and when I want to take it over to a actual data, then I have to multiply by N. Okay. Okay, this we've already done. Mutually exhaustive event, this is equal to 1. Okay. Now let us go to the 8th sum. Yes, Sonali, Amit, Jyoti, Vanshika, Sagar, Sarvesh, Madina, Zebba, Chahal, Ishan, Bibu, Gunjan, Soumya, Shivangi, Rekha, Divya and Rafika. A very good afternoon to all of you also. Okay. So now we are considering this. Okay. 3 mutually exclusive exhaustive. Exhaustive means what? Their total probability should come to 1. Okay. We have just now done it. So let us see. Okay. So there are 3 events which are mutually exclusive and exhaustive. So that what is given to me is P of A is equal to 2 times P of B is equal to 3 times P of C is equal to KC. Okay. So let it be equal to K. So what this means is P of A is equal to K and P of B will be equal to K upon 2 and P of C will be equal to K upon 3. Okay. P of A is equal to 2 times P of B is equal to 3 times P of C is already given in the question. It is given in the question. So I have this. So now what I need to do is I just need this. So What do I have? Now I know that P of A plus P of B plus P of C is equal to 1. Why? Why is it so? Because it is exhaustive. Because it is exhaustive. Bad handwriting. Let me change that. Why I have equated to 1 is because events are exhaustive. Okay. Now what is P of A? That is equal to K. P of B, K by 2 plus K by 3 is equal to 1. This is equal to K. 1 upon 2 is 0.5 K and 1 upon 3 will be equal to 0.333 K is equal to 1. Okay. I can do it this method when I see here decimals. But here see, I am seeing that the answers are in fraction. So instead of doing this, what will I do? I will consider the LCM. Okay. This is also a perfectly valid method. But since the answers are there mentioned in a fraction, I will take a fraction. So this is what? What is the LCM of 1, 2 and 3? That is 6. So this is 6. So this will be 6K. 2 3s are 6. So 3K plus 3 2s are 6. So 2K is equal to 1. 6 and 3, 9. 9 plus 2, 11. So 11K upon 6 is equal to 1. So K will be equal to 6 upon 11. Okay. So answer will be 6 upon 11. Have you understood this? Here we are just using the very important property that these events are exhaustive. So the addition of all the probabilities should come to 1. Yes, people, very good. Yes, Zeba, understood? Yeah. Lakshita, yes. This is from the exercise, okay? Who has asked this? Tanu? This is from the exercise. Now let us go to the next sum. For two events A and B, P of B is given, P of A but not B is given, and P of not A is equal to this. So what will happen? Let us draw a Venn diagram. Let me draw a good Venn diagram. Okay. This is my A. Then this is my B. Okay. So when they are saying P of B is 0.3. So this is P of B is equal to 0.3. Okay. P of A but not B. What does this mean? See, many times what happens is you are not able to visualize. That is why you find it difficult. But if you understand this, see P of A but not B. P of A but not B. Means what? This area is common. Okay. So what will it be? P of A but not B. So we are not considering the area which is common. Now what is that probability? It is 0.4. Okay. 0.4 which is not considering this. Now let me call this as X. Okay. Let me call this as X because I don't know. So if this is X, what will this area be? What will this area be? Because I am not considering that, what will this area be? This area will be, this is whole thing is 0.3. The whole of B is 0.3. How much is this? This is x. So this will be 0.3 minus x. Okay, 0.3 minus x. Now what they are saying is that P of A but not B is 0.3 and P not A means everything apart from A is 0.6. So that if this is my universal space, then if I remove this A, whatever remains will be 0.3, 0.6. Okay, I will just show you over here how it will look like. Means what? This is my A. Okay. And everything remaining will be not A. How much is this? This is equal to 0.6. This is equal to 0.6. Okay. P not A. Means apart from A, whatever it is, that is 0.6. But now, what do I know? This area I know 0.3 minus x. So what I do is, okay, so this much area is 0.3 minus x. So what will that be? So how much will this be? Because the whole thing was 0.6. So this area will be equal to 0.6 minus 0.3 minus x. Okay, this area will be 0.6 minus 0.3 minus x. Because this is 0.3 minus x, this area is 0.3 minus x. The whole thing is 0.6. So if I subtract from that, so what will this be? 0.6 minus 0.3 plus x. So this will be equal to 0.3 plus x. Okay. So that this area is 0.3 plus x. Now how much is this? This is 0.4 plus x. How much is this? 0.3 minus x. This whole thing is 0.4 plus x. How much is this? This is 0.3 minus x. Now I know that when I add all this, so what will it be? 0.4 plus x plus 0.3 plus 0.3 0.3 minus x plus this remaining area plus 0.3 plus x. Okay. So what have I considered? Which are the areas I have considered? Let me just tell you. This is my first area. Okay. This is my second area. And this is my third area. Okay. If I add this, this and this, what do I get? I get the whole sample space. I get the whole sample space. So this should be equal to 1. This probability plus this probability plus the remaining probability is equal to 1. So what will this be? 0.4 plus x minus x will get cancelled. And what will happen? 0.4 plus 0.3 plus 0.3 plus x is equal to 1. Okay. This x and this x is cancelled, but 1 x still remains. How much is this? 0.4 plus 0.3, 0.7 plus this 1. 1 plus x is equal to 1. How much is x? X is 1 minus 1, which is equal to 0. Okay. Since this is equal to 0, when do we have that? Then when they are mutually exclusive. When they are mutually exclusive. Okay. So I explain once again. The first I will plot what is information is given to me. Okay. So what is information? P of B is given to me as 0.3. This I have written. but P of A but not B is given, so I've written that also. And P not A is 0.6, so for that I have drawn a second diagram, and from that I have found out what is the area which excludes A and B. What remains is 0.6, 0.3 plus X. So in the universal space, what do I have? I have 0.4 plus X, then I have X, 0.3 minus X, and then I have 0.3 plus X, and that gives me X is equal to 0, which means that when this is equal to 0, that they are mutually exclusive. Okay, that they are mutually exclusive. Now let us go to the next sum. Ms. Rahul Samira. Yes, they've understood. Very good. Nine sum, they have not asked probability of B. For two events A and B, P of B is already given to you as 0.3. Okay, Gurleen? Okay, in the earlier sum. Oh yes, K, we have found K. Okay, sorry. Yeah, very right. Let me correct this. I found out K. Now I need to find out P of B. P of B is equal to K by 2. So this will be equal to 6 by 11 into 1 half. Okay, so 2 ones are, 2 threes are, so this will be 3 upon 11. So this will be the correct answer. Okay, this is the value of K, but P of B they have asked. Very right. Yeah, thank you for pointing it out. Yes. Now, why consider, Sudhanshu, why consider exhaustive? It is given they are exhaustive. Using that property only, I am able to find out the probability. Okay. Yes, Chanda. Good afternoon. Yes, Himanshu, mutually exclusive is right. Yes, Bibu, right. You are correct. Bhagat, all these questions are from the exercise, right? Yes, Sakshi, now you've understood because I calculated K and then P of B is K by 2. Okay, P of B is K by 2. So answer is 3 by 11. Yes, Shivangi, good. Understood. So Emma, just check. Okay, just check. This thing is mutually exclusive. Okay. Yes. Yes, Shivangi, you have understood it. Excellent. Now let us go to the 10th sum. A bag contains 12 balls which are numbered from 1 to 12. Okay, so I have a ball and I put in 12 balls, and when I put in the balls, I put numbers on it 1, 2, 3, 4. Okay, how up to 12. Then if a ball is selected at random, what is the probability that the number on the ball will be a multiple of 5 or 6? So what are the numbers I'm going to put? Numbers will be 1, 2, 3 up to 12. Okay. Now, which of these numbers are multiple of 5? Okay. So I know from here which will be the two numbers and which of these numbers are multiples of 6. Can you quickly put in the chat box Out of the numbers 1 to 12, which of the numbers are multiples of 5 and which are multiples of 6? Quickly. Yes, Lakshita, very good. You remembered. So this is 5 and 10. Now, multiples of 6? Yes, quickly. Yes, 6 and 12. Okay. So how many numbers are there? 1, 2, 3, 4. So which is that is equal to 5, 6, 10 and 12. So what is the probability that the number on the ball will be a multiple of 5 or 6? This will be probability 5 or 6 will be equal to 1, 2, 3, 4. This is 4 upon 12. So answer is 4 ones are 4 threes are. So it is 1 upon 3. So D will be the correct answer. Right? Yes. Now let us go to the next sum. Yeah, very good. Very good, Himanshu. Vivek, Saima, Rohini, Mansi, Diksha. Yeah, very nice. Arisha, Kalkoti, Sonali, Avinash, Vivek, Avdesh. Okay, good, good, good. Vibhul, Liza, Rohini, Sudhanshu is also good. The answer. Okay, now next one. Given that the two events A and B, P of A is this much, P of B is this much, and P of A union B is this much, what is the probability of A given B? Probability of A given B, what is the formula? P of A intersection B upon P of B. Okay. Whatever is written after the slash, I'm going to write in the denominator. What is given to me? P of A is equal to 3 upon 5. What else is given to me? P of B is equal to 2 upon 3. And P of A union B is equal to 3 upon 4. Okay. Now, do I have P intersection B? I need this. Okay, I need this. Now, do I have it over here? I don't. So, but I know the formula. Which formula? Okay, what we have done and said. Similarly, P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay. Now what happens is, this is equal to how much? P of A is 3 by 5 plus P of B is 2 by 3 and P of A union B is 3 by 4 minus P of A intersection B. So how much is this? This is equal to upon 15. 3 threes are 9 and 5 twos are 10 minus Yes, thank you. Sorry for that gap. So, अच्छा यहाँ पर डाल दो या चैट बॉक्स पे डाल दो ओके मिल गया यस थैंक यू yes thank you so we were talking about this that we are trying to find out p of a given b now when I want to find that I must find p of a intersection b upon p of b now here I don't have p of a intersection b directly but information is given to me about p of a p of b and p of a union b using that I'm going to find out p of a intersection b. So we were up till there. So 3 upon 4 is equal to 3 upon 5 plus 2 upon 3 minus P of A intersection B. Okay. So now this LCM, 5 and 3 LCM is 15. So what will happen over here? This will be 9 plus 10 minus P of A intersection B. Okay, this is intersection. Okay, is equal to 3 by 4. So P of A intersection B will be equal to 19 upon 15 minus 3 upon 4, which is equal to upon 60, or you can directly do this on the calculator also. Okay, let's see. So if they give it upon 60, let us see. So this will be 15, 4s are 60. So 19 4s are how much? 19 4s are 76. 19 4s are 76. Okay. And 15 3s are 45. So 76 minus 45 is how much? 31 upon 60. So 31 upon 60 will be the P of A intersection B. But what do we have to find out? We have to find out P of A given B. So this will be equal to 31 upon 60 upon P of B. P of B is how much? 2 by 3. 2 by 3. So this is equal to how much? This is equal to 31 upon 60 into 3 upon 2. So this will be 20. So this will be 31 upon 40. 31 divided by 40 is equal to 0.775. Okay. So D will be the correct answer. Understood? Bhargavi, yes. Pratidna Bhargavi. Yes, 31 upon 60, Lakshita is P intersection B. And then, yes, final answer is 0.775. Himanshu, yes, correct. Zeba, Vanshika, Avdish, yes, D is the correct answer. Lisa, Manchi, Pranav. Okay. Okay, now let us move to the 13th sum. This is an interesting sum. So P of A is equal to P and P of B is equal to Q. Then P of A given B. They want you to find out which of these is true. Okay. They want to find out. Now P of A given B is equal to P of B given A into P of A upon P of B. Okay. Because we up till now we have only done this formula P of A intersection B upon P of B, but this is also a formula. So P of A given B is equal to P of B given A. Okay, so here you can see this is reverse of this. So P of B given A into P of A upon P of B. Now what is P of B given A? P of A is how much? P. And P of B is how much? Q. Now, we know that fundamental property of probability, that probability value is always less than or equal to 1, right? We know that probability lies between 0 and 1. So, any probability value will lie between 0 and 1. So P of B upon A will always be less than or equal to 1. So if this is there, if this is the condition, then P of A given B, this P of A given B will be less than or equal to, because this number is less than or equal to 1 star P upon Q. Because P of B given A is less than or equal to 1. So this whole thing will also be less than or equal to P upon Q. Okay. So A will be the correct answer. Now 14th question. P of A dash union B dash is equal to 5 by 6. P of A is given. P of B dash is given, which is equal to 2 by 3. What is P of A union B? Okay. Now what is the formula? P of A union B is equal to P of A plus P of B plus and minus P of A intersection B. Also I know P of B dash is equal to 1 minus P of B. So P of B will be equal to 1 minus P of B dash. Okay. Why I need this? Because here I have been given P of B dash. So here also I am able to find out. From there I find out P of B. So P of A I already know here. This is my first. P of B I will know from here second. Now comes this problem, that P of A intersection B. How do I find that out? Okay. For that they have given us this information that P of A dash union B dash. Okay. Now what is A dash union B dash? Will be equal to P of A union B dash. Okay. Which is equal to which will be equal to P of A intersection B, which is equal to A intersection B. Remember we have done in sets? Remember we have done in sets? Okay. So this is equal to how much? This is equal to 1 minus same formula. P of B dash is equal to 1 of P of B. So P of A intersection B dash will be equal to 1 minus P of A intersection B. Okay. If you're not able to find this out immediately, let me show you. You can even draw the Venn diagram to understand this. This is my A and this is my B. Okay. What I want is A dash union B dash, so that whatever is not A, and this is my A and this is my B, whatever is not A and not B. So which area will this be? A dash union B dash. Okay. So all this will be, what will that be? That will be A intersection B. 1 minus A intersection B. Because what is A dash? This is A dash. Okay. This is my A dash. And what is my B dash? B dash will consider this also. B dash I will consider this also. Okay. So it will be nothing but 1 minus A intersection B dash. 1 minus A intersection B dash. So except for this, okay, except for this area, everything else will be your A dash union B dash. So P of this will be A intersection B. Now this I know is given to me is how much? 5 by 6. So 5 by 6 is equal to 1 minus P of A intersection B, or P of A intersection B is equal to 1 minus 5 by 6, which is equal to 1 upon 6, which is equal to 1 upon 6. So now I have P of A, I have P of B, and this is my P of A, this is my P of B, and this is my third thing, that is P of A intersection B. Substituting in the formula, I have P of A union B to be equal to P of A is how much? 1/2. P of B is how much? From here I have calculated, which will be equal to 1 minus 2 by 3, which is equal to 1 by 3. So plus 1 by 3 minus how much? 1 by 6. So what is the LCM? 6. So this is 3 plus 2 minus 1. So 5 minus 1, which is equal to 4 by 6, which is equal to 2 by 3. So P of A union B will be equal to 2 by 3. Clear? Adesh, that I've already answered yesterday also. Okay. Now let us go to the 15th sum. Whenever you hear this word for two independent events, so what does this mean? P of A intersection B is equal to P of A into P of B. Okay. So that if for two independent events A and B, P of A union B is this, P of A is this, what is P of B? Okay. So now here what do I have? I don't have intersection. I have information about P of A union B to be equal to 2 by 3. Then I have P of B, P of A to be equal to 2 by 5. Okay. P of A, let me write it properly. P of A is equal to this thing. So P of A intersection B will be equal to PA into PB. Now I already know that, what is the formula I know? P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay. Now P of A is equal to, this is equal to P of A plus P of B, and instead of A intersection B, what will I write? Minus P of A into P of B. Okay. So now I've got the formula. So P of A is how much? 2 by 5. P of B is how much? I don't know. Again, minus 2 by 5 into P of B. Okay. And how much is P of A union B? This is equal to 2 by 3. Which is equal to 2 by 5. 2 by 3 is equal to 2 by 5. 1 minus 2 by 5. Okay. Plus 1 minus 2 by 5 will be equal to 3 by 5 PB. 3 by 5 PB. Okay. So let me simplify this. I take this 2 by 5 onto this side. So I will get 2 by 3 minus 2 by 5 is equal to how much? Upon 15, which is equal to 10 minus 6, which is equal to 4. 10 minus 6 is equal to 4 is equal to 3 by 5 PB. Okay. This I took to this side and I subtracted, and on the right hand side I have 3 by 5 PB. Okay. So I will get PB will be equal to 4 upon 15 into 5 upon 3. PB is 4 upon 15 into 5 by 3. 5 ones are, 5 threes are. Answer is 4 upon 9. Okay, so B will be the correct answer. Okay, so here the most important word is independent. Because of that, I have been able to use P of A intersection B is equal to P of A into P of B. Zeba 14th. See, what is happening here is that it is A dash union B dash. Okay, P of A dash union B dash. So when I try to put this on a graph, I will see that on the Venn diagram. So I see that A dash means everything apart from A, and B dash is everything apart from B. And I get this when I try to map it. Or you can use the formula that A dash union B dash is equal to A intersection B dash. Okay. So that formula also I can use, and then I can get this. P of A dash union B dash is equal to 1 minus P of A intersection B, and from there I can get the answer. Okay. Now going to the 16th sum. Yes, Vanshika, correct, Avdesh. Yes. So Emma, you have to keep practicing. You then automatically, once you are doing sums, those formulas you will learn. Okay. Diksha, please pay attention. When you are saying that two events are independent, what does it mean is P of A intersection B is equal to P of A into P of B. Now, this I'm going to use in the normal formula. A union B is equal to P of A plus P of B minus P of A intersection B. Instead of A intersection B, what I'm going to write? I'm going to write out P of A into P of B. P of A, I already have the value, which is equal to 2 by 5. I substituted the value of P of A and P of A intersect A union B, and from there I found the value of PB. Now here in the 16th sum, P of A is given, P of B is given, P of A given B is given, and then they're asking you to find out the value of P of B given A. Just in two sums before, we have done that P of B given A is equal to P of A given B into P of B upon P of A. Okay. So this is in the denominator, so it will also come here in the denominator. Okay. Now P of A given B is how much? 2 by 3 into P of B is how much? 3 by 4 upon how much? P of A, that is 2 by 3. So this is equal to 3 ones are, 3 ones are, 2 ones are, 2 twos are. So 1 upon 2 into 3 upon 2, which is equal to 3 upon 4. So P of B given A is 3 by 4. Okay, for this you need to know this formula. Okay, this formula is important. Then we go to the 19th I will be doing last. Okay. So first let me do as many sums as possible. Sakshi, I explained 15 sum right now only, no? Just now I explained. You have to pay attention to the word two independent events. When events are independent, okay, so if you want, you can write it down also. When events are independent, P of A intersection B is equal to P of A into P of B. Okay. Sakshi, I hope you understood. Yes, Himanshu understood. Yes, Bibu. A union B A union B is 5 by 3. 2 by 3 दिया ना Bibu? A union B is given to you as 2 by 3. B 5 by 3 कैसे आ जाएगा? See here, okay. This, don't get confused. Here, this we are solving, okay? What is that? If we have any place. What do I have over there? That is P of B minus 2 by 5 P of B. Okay. This is as good as x minus 2x by 5. Okay. This is as good as this. You know how to solve this, right? This is LCM here is 1. So 1 and 5 LCM is 5. So this is 5x minus 2x which is equal to 3x upon 5. Okay. Instead of 3x upon 5, what I have written? 3 PB upon 5. Okay. So this is how you have to solve it. Okay, so in 14th also, P of A union B is P of A plus P of B minus P of A intersection B. This I know, and I need to now find out P of A intersection B. So this I find out using these formula for A dash union B dash. Okay. So Sprit. 20th sum, I want you to all try because yesterday we have given a lot of time for coins also. So the answer P of A plus B and A union B are, we don't have P of A plus B here. Okay. We have union only, or P of A minus B or B minus A. So 20th we will be doing. 19th and 20th I'll take up later. 21st, where is it? Yes. Okay, yes, expected value sum I wanted to take. Now expected value. These are very much possible. Expected value sum. Okay. Expected value is what? Summation of x into p. Okay. Now I have x and I have the probability. What are the values of x that are possible? 0, 1, 2. Okay, x assumes the value 0, 1, 2 and probability is 0.3, 0.5 and 0.2. 0.3, 0.5 and 0.2. Okay, so expected value is x into p. So what will this be? 0 into 0.3 plus 1 into 0.5 plus 2 into 0.4. So this is 0, this is 0.5, and this will be 0.4. Oh no, 0 into 0.2. So this will be equal to 0.90. So C will be the correct answer. Okay. Okay. So we take a break because then we will do more sums and more theory also. Okay. So let us take a 5 minutes break, and then when we come back, we will do further sums. Okay. So again, somebody was asking me for the marks, weightage. So this is probability and theoretical distributions together will constitute for 25 to 30% of your marks of statistics. Okay. So then we have talked about what is mutually exclusive, exhaustive, and equally likely. Then we have talked about what is the definition of classical definition of probability and the Laplace definition of probability. Then we have talked about expected value. So that sum also we have done just now. So you can get sums on expected value and variance. Okay, so for calculating variance, you must also know E of x square. So E of x square minus mu square will be your variance, and standard deviation will be square root of this variance. As already told, always remember probability is always a positive quantity and is always less than or equal to 1. If A is an impossible event, probability is 0. If A is a sure event, probability is 1. Okay. Then odds in favor of A is n of A is to n of n minus n of A. And odds against A is n minus na is to na. Okay. So this also we will be needing. Again, talking of deck of cards, we remember that the deck of cards contains 52 cards, 13 of each of hearts, spades, diamonds, and clubs. Okay, there are 4 aces and it contains 4 jacks, 4 aces, 4 queens, and 4 kings. So the total picture cards are 12. And then we have this conditional probability P of B given A is equal to P A intersection B upon P of A. Then P of A intersection B is P of A star P of B given A star P of A. Also, if we have this kind of equation P of A minus B plus P of B minus A means what? Of the universal space, I'm considering only A. I'm not considering A intersection B. So only A. And then if I add only B, what will these two give me? These two will give me P of A plus P of B minus 2 times P of A intersection B. And expected frequency is N star P A union B. Mutually exclusive P A intersection B is 0. So P of A union B is P of A plus P of B. Mutually exhaustive events, it is equal to 1. Equally likely is P of A is equal to P of B. Then we have P of A given, P of B given A is P of B intersection A, which is the same as A intersection B upon P of A. Provided P of A is greater than 0. That is, A is not an impossible event. This can be a theory question that is asked, that where you must know this, that P of A should be greater than 0, or that is P is not an impossible event, then only you can find out P of B given A. That is because P of B given A means what? That is, we are trying to find the probability of event B occurring, provided that event A has already occurred. Now, if A is an impossible event, A will not occur. So finding this P of B given A, that is a conditional probability, will have no meaning. I will have meaning of P given A, that is A event has already occurred and now B has occurred. So what is that probability? That probability we have found out. So this was B given A, and similarly you have A given B, provided P of B is greater than 0. Now we have talked about this as two events. Now if we have 3 events A, B, C, what will be the case? Now if we have 3 events A, B, C, and these are known to be independent. If I have 3 events A, B, C, and they are independent, that P of A intersection B is equal to P of A into P of B. P of A intersection C is equal to P of A into P of C. Similarly, then P of A intersection B intersection C will be equal to P of A into P of B into P of C. It may be further noted that if two events A and B are independent, then the following pairs of events are also independent. That is, this is also a very good theory question. If A and B are independent, then A and B dash will also be independent. So if A and B are independent, then A and B dash will also be independent. A dash and B will also be independent, and A dash and B dash will also be independent. Okay, so this is the sweetest thing that happens here. When you have three independent things, then also these relations are there. A and B are independent, then A and B dash is also independent, A dash and B is also independent, and A dash and B dash is also independent. Now let us see this question. Example 15.11. A number is selected at random from first 1000 natural number. What is the probability that it will be a multiple of 5 or 9? Okay, so number of numbers which are multiples of 5. How do I find this out? This will be equal to, what is the number total? 1000. So I divide 1000 on the calculator, divide 1000 by 5. What will you get? You will get 200. Okay. Similarly, number of numbers which are multiples of 9. Now what do? I take 1000, I divide it by 9. So I get 111. Okay. So that means there are 111 numbers which are multiples of 9. Okay. Then also I know that I am finding out this, that it can be a multiple of 5 and multiple of 9, but it can be also a multiple of 45. So number of numbers which are multiples of 45. Why do I need to find it? Because I don't want to add them twice, because once they are divisible by 5, the number which is divisible by 45 is also divisible by 5 as well as 9. So I want to count them only one time. So that is why I need to know this. So 1000 divided by 45. How much is this? 22. So that probability of number being multiple of 5 or 9, so 5 or 9 is equal to P of A, that is probability of it being a multiple of 5 plus probability of it being multiple of 9 minus probability of multiple of 5 as well as 9. That is 45. Okay. So if I do that, what will happen is I will eliminate this, that I am taking this number only once, I am eliminated which are common. Okay. So I don't have to count them twice. So P of A is 200 upon how much is the total number of numbers? 1000 plus P of B is 111 upon 1000 and minus 22 upon 1000. So this is equal to how much? 200 plus 111 minus 22, that is 289 upon 1000. So answer will be equal to 0.289, which I can also write it as nearly equal to 0.29. Okay. So I hope you've understood this. Then going to the next sum. This is the expected frequency sum. Yes, very good, Bhumika, Diksha, Pranav, Vibhu. Yes, Sakshi, Bhumika, Jia. Yes, very good. Okay. Now let us go to the next example. The probability that an accountant job applicant has a BCom degree and is a CA is this much, and that his both is this much. Out of 500 applicants, how many would be BCom or CA? Okay, so there is a job posting. So a person can be a BCom, he can be a CA, or he can be a BCom CA. Okay, like all of you will become BCom and CA, right? So BCom, CA, or BCom or CA. Now what they are saying, the probability that an accountant job applicant has a BCom degree is 0.85. That he is a CA is 0.30 and he has both the degrees is 0.25. Okay. Now, if I want to show it diagrammatically in the Venn diagram, this is my BCom, which is equal to 0.85. Then, change the color. Then he is a CA is 0.30. And his both BCom as well as CA is 0.25. Only CA is how much? 0.505. 0.3 minus 0.25 is this one. If they ask you only CA, your answer is 0.5. 0.05, sorry. And only BCom 0.8 minus 0.25, this is 0.60. Okay, so a job applicant is 0.85, that he is a this thing CA. BCom it is 0.85, and that he is a CA is 0.3, and his both BCom and CA is 0.25. Then what is the, how many would be BCom or CA? Okay, how many would be BCom or CA? Now here I have P of A union B is equal to P of A plus P of B minus P of A intersection B. So here you will be able to find out this is equal to 0.60 plus 0.25, 0.3, P of A is 0.6, and then this is minus 0.25. So this is 9. 0.9 minus 0.25. Okay. 0.9 minus 0.25. Okay, no. I have written the values. So what is the probability that he is a BCom? 0.85. What is the probability he is a CA? 0.30. What is the probability he is a BCom and CA? It is 0.25, which is equal to 0.85 plus 0.30 minus 0.25, which is equal to 0.9. 0.90. Okay. So P of A union B is 0.9. Means what? That how many would be BCom or CA? 0.9 is the probability he will be a BCom and CA. Now expected frequency, that is, when this is my probability, but I want to find out the actual number of people. Out of 500 applicants, how many of them would be BCom or CA? So that is, there may be some people who are neither BCom nor CA, they may be something else. Okay, they may have done their graduation, maybe BA. So excluding that, we are just concentrating on BCom and CA. So expected frequency of this will be 0.9 into N. N is how much? 500, right? Because there are out of 500 applicants. So 0.9 into 500 is 450. So out of the applicants, 500 applicants, 450 will be people who are either BCom or CA or both. Now we go to 15.13. Understood? Yes, Jyoti. Zeba, yes. Samya is clear. Sagar is clear. Bhumika. Yes. If P of A minus B is equal to this much, P of A is equal to this much, and P of this, what is the probability that the two events A and B, only B will occur? Only B will occur. So when I'm talking of only B, so what happens is I have this A and I have this B. Then when I'm talking about only B, means what? This area. Okay, we are talking about only this area. So what happens here is P of A and P of B, they want only B occurs. Now we have this formula, P of A minus B is equal to P of A intersection B dash A minus B. Means what? I want only A, this portion. Okay, I want only this portion. Or I can even, like now I'm talking about this. This is B minus A. Okay, this is B minus A, which is equal to PB minus this A intersection B. What happens is, how do I calculate B minus A? I have this B, this is my B. Out of them, when I remove A intersection B, this is A intersection B. If when I remove this, what I get is A, B of B minus A. Okay. Now what is happening is A minus B, P of A minus B is equal to P of A minus P of A intersection B. P of A, B minus A is 1 by 5, P of A is 1 by 3 minus P of A intersection B. Now P of A intersection B will be equal to 1/3 minus 1 upon 5. 1/3 minus 1 upon 5. So what will be the answer? Yes. Given me P of A intersection B, but what are they saying? Only B would occur. Only B would occur means what? I need to find out P of B minus A. Only B would occur. So this is equal to how much? P of B minus P of A intersection B. A intersection B I've just now calculated as 2 by 15. How much is P of B? It's already given to me as half. Half minus 2 upon 15. So which is equal to upon 30 is 15 minus 4, which is equal to 11 upon 30. Okay, will be the answer. I hope you've understood this. Yes, very good. Chahal has understood. Yes, Diksha. Jyoti, understood now? Yes, good. Yes, very good. We were crystal clear? Yes. Samya, you got the correct answer. Yeah. Now let us go to The next. There are three persons A, B and C having different ages. The probability that A survives another 5 years is 0.8, B survives another 5 years is 0.6 and C survives another 5 years is 0.5. The probabilities that A and B survive another 5 years is 0.46, B and C is 0.32 and A and C is 0.48. The probability that all three survive another 5 years is 0.26. Find the probability that at least one of them survives another 5 years. At least one. Now, what is given to you? Now, okay. For that, now as there are three people, normally we talked about two people, P of A union B. But now there are three people because they are saying at least one is survived. Means what? I must find P of A union B union C. So that at least one senior citizen has to survive. Okay. It's not senior citizen, any person. So any person can survive. So they have taken three people, talked about their life expectancy, and then we are trying to find out what is the probability that at least one of them will survive. Where do you use this? This you use in actuarials. Okay, actuarials is a science which studies or which is used to study life expectancy and what are the premiums that you pay on your LIC policy or your health policy. That study requires this all information, and these people use a lot of statistical tools for that. So P of A union B is union C is equal to this. Now P of A is given to me as 0.80 plus P of B is given to me as 0.60 plus P of C is given to me as 0.50. P of A intersection B. The probability that A and B survive another and the C and means what this intersection. So A and B survive another 5 years is 0.46 minus 0.32 minus 0.48 plus 0.26 plus 0.26, which is equal to how much? Can we find out? 0.8 plus 0.6 plus 0.5 plus 9 minus 0.46, 0.32 minus 0.48 plus 0.26. It is 0.9, which is equal to 0.90. So this will be the correct answer. Okay. So here you must know all the formulae and then it becomes easily understood. Perfectly understood, Lakshita? Yes. Yes, Avinash, Saima? Yeah, Divya is understood? Yes. Pranav is understood. Vanchika is understood. See, what are they saying? They are saying that there are three people, A, B and C. Okay, pay attention. Jyoti, Saima. Okay. So what happens? There are three people. The life expectancy of first person A is that he will live another 5 years is 0.8. Means he is nearly definitely going to live. So the rate is given, the probability is given as 0.8. Then B's chance that he will be alive after 5 years is 0.6 and that of C is 0.52. When we are talking A and B, okay, I want that if A and B both should survive, what is that probability? It is 0.46. It is 0.46. What does this 0.46 mean? It means what does this 0.46 mean? This 0.46 means that the probability of both A and B will survive. Okay, both A and B will survive is 0.6. Similarly, when I'm talking about 0.32, what does this mean? It means that probability of both B and C both will survive. And 0.48 means what? Probability of both A and C will survive. Okay. So this is there. And what is the probability? 0.26. What does this mean? That all three will survive another 5 years. Okay, what 0.26 means? That this is a probability that all three, A, B and C, will survive another 5 years. So now I know what is the individual expectancy that they are going to survive. I also know when two of them together are taken, when how much they will survive. And I also know from the question itself, I have come to know that what is the probability that all three will survive. Now, what I want to know is, out of these three, at least one should survive. What is that probability? That probability I've got as 0.90. So 90% chance is there that out of these three people, at least one will survive. Okay. Have you understood now? Has everybody understood? This is important that you understand the concept of probability. Yes, crystal clear. Swati, Bhumika, Zeba, Diksha. Yes, Chahal. Yes, very good. Saima, have you understood now? Avinash? Jyoti? Yeah. Okay. Now, these are also good questions that we are going to take up now. Is Rupesh is known to hit a target in 5 out of 9 shots, whereas David is known to hit the same target in 6 out of 11 shots. What is the probability that the target would be hit once they both try? Okay, so there are two shooters. One is Rupesh, one is David. When Rupesh shoots, when he shoots 5 shots, out of them, 9 shots, out of them, 5 hit the target. Okay. But when David shoots, he shoots 11 shots. Out of these 11, 6 are reaching the target. Now, what we want to find out that when either of them has shot, at least the target is hit once they both try. Okay. So what is happening is that you must realize that these two events are independent. Whether Rupesh can hit the target is not dependent on whether David can hit the target. Okay. So this is a very important factor that you should see. Whenever such questions are given, try to understand whether A intersection B will be, there will be an intersection of A and B, or if they are independent, then it will be P of A into P of B. Okay, so this is an important thing that you must remember, that these two, Rupesh hitting the target and David hitting the target, are completely independent. Therefore, we say that what they are saying is the target would be hit once they both try. So means what? I have to find A union B, because at least once it should hit the target. So what is this? P of A union B is equal to P of A plus P of B minus P of A intersection B. Normally, if information is not given, I would not be able to find out. But because I know that Rupesh and David are independent of each other, I am able to use this formula. P of A intersection B is P of A into P of B. So this is equal to 5 upon 9 What is the probability of A? It is 5 upon 9. What is the probability of B? 6 upon 11. What is the probability of A intersection B? It will be 5 upon 9 into 6 upon 11. So this is equal to how much? Upon 99. 11 5s are 55 plus 9 6 are 56. 54, sorry. 54. Minus this is 30. This is equal to 109 minus 30. 109 minus 30 upon 99. So how much will this be? 109 minus 30. 79. This is equal to 79 upon 99. Okay. Once again, I tell you that when such sums come, you have to find out whether they are independent or not. If they are independent, remember to use the formula P of A intersection B is equal to P of A into P of B. Then P of A union B will be equal to P of A plus P of B minus P of A intersection B. So instead of P of A intersection B, I write down the formula and find the answer. Yes, Gurleen? Yes, Sagar, Pratibhya, Chahar, Vibhu, yes. So, what is happening here is that we have two people who are shooting the target. Shooting by one person is unaffected by shooting of another because they are independent of each other. So, I am using the formula P of A intersection B is equal to P of A into P of B. A pair of dice is thrown and the sum of points of the two dice is noted to be 10. What is the probability that one of the dice has a show the point 4? Okay. So what has happened? Two dice are thrown. Okay. The total on the top face, total is equal to 10 is given. When will the two dice have a total of 10? Let us see. When one dice 1, now this is dice 1 and this is dice 2 and total. Okay, if I have dice on the face of dice 1, maximum is how much? 6. 1 plus 6 is 7. So is it equal to 10? No. With 2, what is the maximum? 6. 2 plus 6 is 8. Is it equal to 10? No. With 3, maximum is 6. How much is this? This is equal to 9. Is it equal to 10? No. With 4, 4 plus 6, 10. Okay. So, this is one possibility. Now, if I have 5, then if I try to write down 6, 5 plus 6 is 11. So, it is more than 10. So, let me write down 5 and 5. How much is 5 plus 5? That is 10. Okay, so this is also a possibility. So this is also a possibility. Then I have six and 6, which is 12. That I don't know. That I don't want. Then 6 and 5, which is equal to 11. Then 6 and 4, which is equal to 10. Okay, so this is also possible. So what is my sample space? Here, I have written it over here. Sample space is 4, 6, 5, 5 and 6, 4. But Out of them, which of them are the cases where I get a 4 also? So in this I have got a 4, in this I have got a 4. So probability of getting a 4 is equal to 2 upon 3. 1, 2, 3 is there and 2 is in the numerator. Okay, because there are two possibilities where you will have 4 on the top and the total will be equal to 10. Bala, what happened? Just remember, independent means P of A into P of B. Lakshita, not 3 by 10, 2 by 3. 10 is the total. Okay, they just want the total on the dice to be 10. Okay. Pranav, you can see the earlier set video of set that you will be able to understand. चार 6 कौन सा 6? ये डाइस होता है उस पे 1 2 3 4 5 6 तक होता है ना, जब लूडो खेलते हैं आप तो उसके ऊपर जो नंबर्स होते हैं तो वो मैक्सिमम 6 होता है. 1 2 3 4 5 6. Like now if I'm starting with 1 plus 6 is 7, so it is not equal to 10, so I leave the ones. Then I take up the 2s. If on one dice I get 2, what is the maximum I can get on the second dice? 6. 2 plus 6 is 8, so I don't consider 2 also. 3 plus 6 is 9, so I don't consider 3 also. But if I get a 4 on one of the dice, so what can happen? Then when I get a 6 on the other dice, that total is equal to 10, because this is important that they have already told us that the should be equal to 10. Okay, here they have given us that it should be equal to 10. Okay, Lakshita, fine. Sama, they are already there in the PDF that has been uploaded. Okay, everything is there. Now I have a group of people. Okay. I have a group of people. This group of people contain 12 male, no, 20 males. They contain 20 males and 15 females. Okay, so this total group is of 35 people. 35 people. Out of these 35 people, some of them are service holders. Some of them are non-service holders. Now, how many service holders are there? In them, they have 12 males and 8 females are service holders. So, 12 males plus 8 females, which is equal to 20. Total 20 people are service holders. Now, I do not need to worry about non-service holders, because the question is that what is the probability that a person selected at random from the group is a service holder, given that the selected person is a male. Okay. So what they want to say is, when you select that person, I know that he is a male, and now I want to find out whether he is a serviceman or not. Okay. When I'm selecting a person, I have already selected a male. After that, I want to know whether he's a serviceman or not. So we have probability whether he's a serviceman, given that he's a male, is given by P of serviceman intersection male upon P of male. Okay. Now, P of servicemen intersection male. How many servicemen are there? Total 20. How many male are there? 12. What is the probability? This is 12 upon 20. Now, what is the probability he is a male? So, 20 upon 35. Okay. So, he's a serviceman and male. Okay. Just okay, here I will have to show you this. Male, there is no problem. 20 out of 35 are male. 20 people out of 35 are male. Now, service holders. So, what happens here is, how many service holders do I have? 12. And how many males do I have? Out of the 20, 12 are service holders. Okay. Out of the 20, 12 are service holders. So, I have a total of, in this, I want to find out service holders and male. Service holders, this is intersection. So, service holder and male. So, how many are there? There are 12. How many are there total? Total is 30. Okay. I will show you on the Venn diagram also. Okay. This is my service holders and this is my males. Okay. So, service holders and males. So, what happened? How many males are there? Total. Out of them, how many service holders are there? 20. This is out of these 20. This is service holder and this is male. What is this? These are the people who are service holders and male. How many are there? 12, because they have already given to us. So that means how many males are there who are not service holders? There are 8 males. Out of the service holders, 12 are males. So what happens? 8 are females. Okay, 8 are females. So 8 are females, 12 are male. Okay. So this is how it represents. So this is 12 upon 35 upon 20 upon 35. So this is 12 upon 20, which is equal to 0.60. Next question is, in a connection with a random experiment, it is found that P of A is 2 by 3, P of B is 3 by 5, and P of A union B is 5 by 6. Evaluate the following probabilities. Okay. So this is an important sum. You can mark it also here important. So that this will cover all your formulae. Okay. This will cover all your formulae. Because they are asking you to find out P of A given B, P of B given A, P of A dash given B, P of A given B dash, and P of A dash given B dash. Now, from this, I can find out P of A intersection B. P of A union B is equal to P of A plus P of B minus P of A intersection B. Now how much is this? This is given to me as 5 by 6. This is 2 by 3 plus 3 by 5 minus P of A intersection B. So how much is this? P of A intersection B is equal to 2 by 3 plus 3 by 5 minus 5 by 6. H is equal to upon 30. So this is equal to 15 twos, 10 twos are 20 plus 6 fives are 15 minus 25. So 35 minus 25 is 1 by 3. 35 minus 25 is 10. 10 upon 30 is 1 by 3. Now first is P of A in A given B. So 1 by 3 upon P of A given B. So I'm trying to find the first one. Upon P of B is how much? 3 upon 5. So this is equal to 1 upon 5. No, how much is it? 1 upon 3. One upon 3 into 5 upon 3, which is equal to 5 upon 9 will be the answer for the first one. P of A given B. Now P of B given A. P of B given A P of B given A will be equal to P of A intersection B upon P of A, which is equal to P of A intersection B is 1 by 3, P of A is 2 by 3, which is equal to half. Okay, that is the second one. Third one is this P of A given B we have done, P of B given A we have done. Now P of A dash given B. Now P of A dash given B will be equal to P of A dash intersection B upon B. Now instead of this, I can write this as P of B minus P of A intersection B upon P of B. How much is P of B? 3 by 5. P of A intersection B is 1 by 3. And P of B is how much? 3 by 5. Okay, so this is equal to 9 minus 5 upon 3 upon 5, which is equal to 4. 9 minus 5 upon 3 by 5. Now, let me check. A intersection B is 1 by 3. So let me see. This is nine minus 5, which is 4 upon 3 upon 5. A dash intersection B. Where did this go? A dash A intersection B is 2 by 3 plus 3 by 5 minus 5 by 6. Okay, so this is how much? This is 30. So 10 into 2, 20. 5 into 6 3 okay, 18. That's why. Here I made a mistake. So this is 18 upon 25 upon 30. Okay. So 20 plus 18 is 38 minus 25, which is equal to 13. Okay. So answer is not 1 by 3. It is 13 upon 30. See why I realize this, that I have made a mistake. See, very important. I will show you. Here I was getting 4 upon 3. Probability cannot be greater than 1. So automatically I realized I have made a mistake. So here I am now getting 13 upon 30. Instead of 18, I have written 15. So it is now 13 upon 30. So now I've got the value of this. So these figures will all change. So first is P of A given B. P of A given B is equal to 13 upon 30 upon P of B is 3 upon 5. Okay, so this is 5 and 5 6. So this is 13 upon 6 into 1 upon 3. Okay, so this is 13 upon 18. So this is 13 upon 18. Yes. Now P of B given A is 13 upon 30 upon P of A is 2 upon 3. 3 ones are, this 3 tens are. So this is equal to 13 upon 10 into half. So 13 upon 20. Okay. P of this is 13 upon 20. Then A dash, A given B dash, and so now A dash given B, A dash given B, this is equal to 13 upon 30, which is equal to how much? 13 upon 30. So this is equal to how much? Upon 30. So 6 5s are 18 minus 15 upon 3 upon 5. So this is equal to 3 upon 30 into 5 upon 3. So 3 will get cancelled. 5 ones are, 5 6 are. Answer is 1 by 6. Answer is 1 by 6. Okay, just let me write it clearly. Now, what is P of B? P of B is 3 upon 5. What is P of A intersection B? 13 upon 30. What is P of B? 3 upon 5. Now, what is the LCM here? This is 30. So, 5 6 are, 6 5 are 18. And 30 ones are. So, minus 13 upon 3 upon 5. Right? Is this okay till here? Just let me know. Okay. So how much is this? 18 minus 13 is 5 upon 30 upon 3 upon 5. Okay. Right. So how much will this be? This is equal to 1 upon 6 into 5 upon 3. Answer will be 5 upon 18. It will be 5 upon 18. Right? Okay. Yes, understood? Goodlin, where do you want? Yes, Soumya. Yes. अभी clear है ना सौम्य? Yes. So this is 3 by 5 is PB minus 13 upon 30 is P of A intersection B, and then PB is 3 upon 5. Okay. So you've got this clear? Okay. So now we would want P of A given B dash. Okay, P of A given B dash will be P of A intersection B dash. Now, like in the early one, so P of A minus P of A intersection B. Here, what did we do? A dash intersection B, it was PB minus P of A intersection B. Here, it is P of A intersection B dash is PA minus P intersection B. Okay, so now how much is this? This is 2 upon 3 minus 13 upon 30 upon 1 minus, because this is B dash. So 1 minus 3 upon 5. Okay. 1 minus 3 upon 5. So this is how much? Upon 30. So this is 20 minus 13 upon 2 upon 5. 20 minus 13 is 7. 7 upon 30 into 5 upon 2. So this is 5 ones are and 5 6 are. So this is 7 upon 12. Yes. Okay. And then the last one is P of A dash intersection B dash, which is equal to P of A dash intersection B dash upon P of B. P of A dash given B dash is P of A dash intersection B dash upon P of A dash intersection B. Now, if you remember this, that is A dash intersection B dash is equal to nothing but A union B dash. If you remember, A union B dash is A dash intersection B dash. Okay. So union becomes intersection and the complement will go to each of the elements, each of the sets A and B. So using this, I am writing P of A dash intersection B dash. So P of A dash given B dash is equal to P of A dash intersection B dash upon P of B dash. Okay. Now A dash intersection B dash can be written as P of A union B dash upon P of B. Now again A union B dash can be written as how much? 1 minus A union B. Okay. 1 minus A union B. This is probability. So instead of this, I'm going to write 1 minus probability of A union B upon P of B dash. And instead of P of B dash also, I'm going to write 1 minus P of B. Now A union B is 5 by 6. Right? A union B is 5 by 6. 1 minus 5 by 6. Denominator 1 of P of B is 3 by 5. So this will be 1 minus 3 of 3 by 5. Now how much is this? This is equal to 1 by 6 upon 1 minus 3 by 5 is 2 by 5. So this is 1 by 6 into 5 by 2. So this is 7 upon 5 by 12. So this is 5 by 12. Yes. So this is equal, this is equal to 5 by 12. 5 upon 12. Okay. So all you need to understand here is what are the ways in which I can write this, because they may ask you P of A given B. They may ask you P of B given A, P of A given B dash, Okay, so all possible, this sum is important because all possible things are covered. So once you do this sum, this is enough for you to do any sum of this type. Okay, there was a small error of calculation, otherwise the whole concept is very clear to all of you, that what are the formulas we have to use and how we are going to solve it. Okay. Now crystal clear? Yes, very good. Lakshita? Yes. So we stop here today, and thank you for your patient hearing, and have a wonderful day ahead. And hope you've understood the concepts of probability. Do sums, more sums on expectation frequencies. Okay, so those sums are also very important, and you can do these types of sums where this is a comprehensive sum. Once you have done this sum, you will be able to do any sum that is related to A dash and B dash. Okay, so thank you.